Guess who forgot to turn on Do Not Disturb mode while filming a video? This guy. So if you're wondering why the previous video just suddenly cut off, it's because I'm recording this on my iPhone. Somebody called me and stopped the video. Let's see. Dang, that was a good momentum train and it just got interrupted. So let's quickly recap what's happened so far. We're trying to show that the integral of this is this, so we're taking the derivative of this answer, we set it up, but before we did that, we factored out a negative 1/15 cosine of x, so that we will only have to execute the product rule once, and then we're in the midst of cleaning up the results of the product rule. As a consequence of the product rule, we had two distributive properties to set up. One was a triple distribution, one was a double, and we're currently at this juncture, and I was in the midst of saying that a good problem-solving strategy is asking yourself, where am I, which is here, where do I want to be, which is there, sine to the fifth x, what's in your way? One of the glaring things in the way are these cosines. I don't want them, so how do you get rid of the cosines? And the answer is you replace them with something that they're equal to, and hopefully something that contains some sines. But notice that cosine squared of x is equal to 1 minus sine squared of x. That is a variation of a Pythagorean identity you should know, sine squared plus cosine squared equals 1. That means I can replace each cosine squared with the 1 minus sine squared, which fixes the problem of having the cosines. So let's do that carefully. One of the biggest problems in keeping up with an answer like this is miscopying a piece of it. So my eyes are going up and down, making sure that I'm copying everything correctly, up until the point where I have to change something. All right, so here's the first cosine squared. So we're going to open up some parentheses and replace it with 1 minus sine squared of x. And then minus 8/15 sine of x, and here comes another cosine of x, so we'll open up the parentheses, replace it with 1 minus sine squared of x. Now, as a consequence of that, it's going to invoke a couple of more distributions, and I'm betting that everything cleans up nice after this. Our first distribution is this negative 4/5 sine cubed x across the subtraction problem, and our second is this negative 8/15 sine x across this subtraction problem. So let's see where that takes us, and I get the feeling this will be the penultimate line. And if you don't know what penultimate means, P-E-N-U-L-T-I-M-A-T-E, go look it up. Okay, 1/5 sine to the fifth power of x plus 4/15 sine cubed of x plus 8/15 sine of x. Okay, here comes the distribution. This one's easy, it's times 1 minus 4/5 sine cubed of x. Second half, negative times negative is positive, 4/5 sine to the fifth x. That's encouraging because that's 4/5 sine to the fifth x. We'll combine with that to make 1 sine to the fifth, so that's promising. And then distribute over here, we get negative 8/15 sine x times 1, that's easy. Negative 8/15 sine x. And then negative times negative is positive, and then 8/15. And then sine x times sine squared x is sine cubed x. All right, we should be pretty much there. In case you didn't look it up, penultimate means next to last, because ultimate means last or final. All right, so at this point, we would just start gathering like terms. And as I've already mentioned, two of the like terms are what we were hoping for. We have a 1/5 sine to the fifth power of x. Where'd it go? Here it is. Plus 4/5 sine to the fifth power of x. So those combine to make 1. 4/5 plus 1/5 is 5/5, also known as 1. So we do get sine fit to the x. And now I'm going to cross these out only because I'm done with them. This is a pretty common technique that I use when I'm combining like terms. I isolate them by putting a circle or a box around them. I combine them and then cross them out, meaning that I'm done with them. Now let's track down our third powers. Here's a third power. Here's a third power. Here's a third power. And if everything's correct, these should cancel, but I'm not too... Yes, they do. I'm just going to talk it out. If we put together our positive sine cubes, we have 4/15 and 8/15, which is 12/15 positive 12/15, which reduces to positive 4/5, which cancels the negative 4/5. Those are gone. And these remaining guys are flat out opposites. They're gone.